All right, so our first primitive in network of things is the sensors. So a sensor is an electronic utility that measures physical properties such as temperature, acceleration, weight, sound, location, presence, identity, etc. All sensors employ mechanical, electrical, chemical, optical, or other effects at an interface to a controlled process or open environment. Basic properties, assumptions, recommendations, and general statements about sensors include. So I told you that the NIST document Network of Things looks at this problem. I actually shortened it here, so that's just focus on the most important stuff, but I encourage everybody to read NIST document Network of Things. So let's look at some basic assumptions, recommendations, and so on. Sensors are physical. Some may have an internet access capability. Sensor output is data. A sensor may also transmit device identification information, such as via radio frequency identification. Sensors may have an identity or have the identity of the thing to which they are attached. Sensors may have little or no software functionality and computing power. More advanced sensors may have software functionality and computing power. Because, I mean, we have very small but very nice hardware today, but we are still building very small chips like 4-bit microcontrollers and so on. So, you know, not every sensor has the same capability. Sensors may be heterogeneous from different manufacturers and collect data with varying levels of data integrity. This is important because when you start a project, maybe all of your sensors are identical because you buy them as a batch. But in the future, when you want to add more sensors, probably the technology will be changed. So you will buy different stuff. And this time, it will be maybe from a different manufacturer. And its capabilities will be different and so on. Sensors may be associated with fixed geographic location or mobile. Sensors may provide surveillance. Cameras and microphones are sensors. This is important. So in Network of Things, we consider cameras and microphones as sensors, which are very, capable devices. Sensors may have an owner who will have control of the data their sensors collect, who is allowed to access it and when. This is important. It may not always be publicly available. Sensors will have pedigree, geographic locations of origin and manufacturers. Pedigree may be unknown and suspect. Sensors may be cheap, disposable, and susceptible to wear out over time. Since we are building them in a very cheap way, it should be easy to dispose them by a new one. There may be differentials in sensor security, safety, and reliability, for example, between consumer grade, military grade, and industrial grade, etc. Not many people know it, but there's a huge difference between consumer grade and industrial grade. When we buy a device, for example, even a router, you think that this is what also people use in industry, but actually it is not. Sensors may return no data, totally flawed data, partially flawed data, or correct and acceptable data. So you have to actually detect if it is correct or not. Sensors may fail completely or intermittently. They may lose sensitivity or calibration. So sensors are expected to return data in certain ranges, for example, between 1 to 100. When ranges are violated, rules may be needed on whether to turn control over to a human or machine when ignoring out-of-bounds data is inappropriate. Sensors may be disposable or serviceable in terms of calibration, sensitivity, or other forms of refresh. Complex and expensive sensors may be repaired instead of replaced, which is nowadays never happens, by the way, because in hardware, current trend is to, throw it away and buy a new one. Sensors may be powered in a variety of ways, including alternative current, solar, wind, battery, or passively via radio waves. So it depends on actually the device you are using. If it's a smart card, yes, it can be passively activated by radio waves. But if you're putting it on the field, probably it is battery powered and so on. Sensors may be acquired off the shelf or built to specification. Sensors acquire data that can be event-driven and driven by manual input, command-driven, or released at predefined times. This is important. It depends on the context. Sensors may have a level of data integrity ascribed. Sensors may have their data encrypted if that sensor has enough capability. Sensors should have the capability to be authenticated as genuine. This is important because if this is not possible, malicious people can add sensors to the network which provide flawed data, and this will poison your data. Sensor data may be sent and communicated to multiple network of things. A sensor may have multiple recipients of its data. Sensor data may be leased to one or more network of things. If, for instance, related companies can share their data this way and so on. The frequency with which sensors release data impacts the data's currency and relevance. Sensors may return valid but stale data. Sensor data may be at rest for long periods of time. A sensor's precision may determine how much information is provided. Uncertainty of sensor data should be considered. Sensors may transmit data about the health of a system, such as is done in prognostics and health management. So in this model, we don't classify humans as sensors. This is important because NIST doesn't think humans as sensors, but some other people think that humans also should be considered as sensors in network of things or Internet of Things. But in this course, and as NIST, we do not classify humans as sensors. Humans are classified as an external utility. They can still act in a sensor-like role by manually feeding data into a network of things workflow and data flow, but they are not sensors. Humans can influence sensor performance through failure to follow policy, sensor misplacements, etc., or the positive analogs. Humans are potential contributors to sensor failures. Security is a concern for sensors if their data is tampered with, stolen, deleted, dropped, or transmitted insecurely, so it can be accessed by unauthorized parties. Building security into specific sensors may or may not be necessary based on the overall system design. Reliability is a concern for sensors. So as you can see, there are many things to be considered, many assumptions are made, and security is always a concern here, and also reliability, because we are obtaining data from sensors and we have to be sure that they are reliable.